Okay, everyone, welcome. Before I get started, can everybody just tell me with a thumbs up if you can hear me and it's audible? Beautiful. Thank you. All right. Welcome, everyone. My name is Brian Munoz. I'm the program director for the Master of Data Science here at UC Irvine. And today we have an amazing speaker that's going to give us a talk on data design and droids. This person is coming from cybersecurity. She is a data scientist by trade, but she's bridging a lot of interdisciplinary arts together. That's really interesting. And it's one of the reasons why we thought she would make an amazing speaker for our program. Usually, the Master of Data Science program hosts one or two speaker talks, and Faye was the perfect choice for starting us off this year. So thank you, Faye. The last thing I will say is that this session is being recorded, and we will do a recap afterwards. But thank you for attending and taking some time out of your day. I will now turn it over to Faye to start the session.
Thanks so much, Brian. And thanks so much also to just the Masters of Data Science program for having me. I'm really excited to chat with you all today and introduce you to one of the artworks that's actually currently on display at UC Irvine. So currently on display at the Beale Center is Catherine Behar's solo show, Acknowledge Work. It's up through April 20th. And you can go any Tuesday or Saturday, 12 to 6 p.m. It's a really fantastic show with a lot of really, really great art. But mostly today, I'm going to be talking about Anonymous Autonomous, which is the set of autonomous office chairs that are on display there. A little bit about myself. So my name is Faye Christoph. In my day job, I work as a privacy engineer, which is a mix of software engineer, data engineer, kind of a Swiss Army knife of a person. But today I'll be talking about Anonymous Autonomous, where I was the creative technologist, software designer, and lead project engineer. And I've been involved with the project for about 5 years now. I started during my time at the University of Michigan, where I was working on my Bachelor of Engineering in Computer Science and my BFA in Intowards Performance. And we had a really, really stellar team that kind of helped make the entire project a reality. In the photo, you can see myself, Catherine Behar, the artist in the middle, and then Karthik Urs, one of our hardware consultants on the right-hand side. This was us at the opening at the Beale Center. You too could see the chairs at eye level. But we had an incredible team that was also backing us. So James Kennedy on the software side, Becca Cuomo on the hardware side, Ian Coert also helping with software, and then Tom Bray, a general wizard. And we were also supported by a bunch of different departments at the University of Michigan, the Stanford School of Art and Design, the Institute for Research on Women and Gender, the Center for Ethics, Society, and Computing, the Robotics Institute, Arts Engine Europe, a bunch of different disciplines. And we'll get into that a little bit more. And then obviously, like, huge thank you to the Beale Center for hosting the entire show and this artwork in particular and giving it its world premiere. In case you get lost on your way, this is how you get from the School of Information and Computer Science up to the Beale Center for Art and Technology. You'll go across the park, go down a small street, and you'll see it. It's a big red building with a banner on the side that says Acknowledge Work. So hopefully you'll be able to find it. And once you get there, you will see the chairs on this large piece of marley that's on the ground. And if you sit around long enough, you'll even see them start to move. And if you really, hang out with the chairs, you'll see them behave a little bit like this. So hopefully you all can see them crawling around. We'll just take a second with them. So that's what you'll see if they're just rolling around on their own. And if you walk up to the chairs yourself, you might see them behave a little bit like this. So the chair will crawl up towards you. And then if you end up in front of it, it'll stop to make sure it doesn't run you over. And then it'll very slowly back up and turn around. So as you're watching these chairs, a couple of things that feel, I think, important to kind of pull out about them. You might notice that the chairs are moving quite slowly. They're kind of crawling along. They're inching through the space. If you see them in person, you'll see that they avoid white paper on the ground. So as you move the paper around, you can actually get them to change the way that they're moving through the space. And as you're doing that, you'll see them actually make decisions and be deliberate, and you can just see them at work thinking of how to navigate the space. There are different ways that we could have coded these chairs that would have made them faster and maybe slicker, or just in general, like more high powered, more high tech. But it was really, really important to Catherine as we were making this project to make sure that the struggle of the chairs was made evident, that the decision making was made evident, and that just in general, you felt like you could feel the chairs at work. And so I think there are a lot of things as we kind of go through this talking about why we designed it a certain way, or why we prioritize certain things over others, that comes back to the kind of initial reason that the piece was made, and some of the aesthetic decisions that Catherine wanted to make sure were present in the piece. So another way of kind of coding all of these chairs would have been to have them end up with this, super well-defined map of the entire space, and then they could really quickly kind of zoom through it. But that wasn't really what we were after. We wanted to have an element of vulnerability. So that's what you can expect to see when you end up at the Beal Center. But we're going to actually go ahead and roll it all the way back and talk a little bit about how this entire project started and how we brought the team together. So this project has been in the works for quite a while. And Catherine has been with the project since 2018 when she conceived of it during a residency at Pioneer Works. I joined the team in 2019 when she brought it to the University of Michigan, where she was working as a visiting artist. And one of the things that she was there to do was she was actually funded by an M-Cubed grant, which requires 3 different schools across different disciplines to come together. So we had the Robotics Institute, Women's Studies, and Art and Design. And I was part of the student team that was then tasked with figuring out how we could take these chairs from a pretty hacky, yes, this is possible prototype stage that had been built out at Pioneer Works and into something that was actually able to be passed off to a gallery and to be operated by people who aren't hackers, but who are, like people in the art world that could take care of these chairs. So in terms of the life cycle of these chairs, they've gone through multiple different versions. And if you think of this as kind of software engineering, these would be like major version releases of some kind. So almost like generations of the chairs. The V2 version that we built out had most of the functionality of the chairs themselves. They were able to move around on their own. They were able to avoid white paper on the ground. We already had a lot of the hardware components that we would use throughout the rest of them, the camera, the LiDAR. And we showed them during this work in progress showing, and we got, feedback and saw how people interacted with the chairs. And all of what we saw then informed what we built in the next version. So we saw that as the chairs were rolling around, they would sometimes get a little bit stuck on larger stacks of paper or with a small divot in the ground. So we realized that we'd have to kind of engineer some solutions to that. We realized that people love to trap the chairs. So we were like, okay, what can we do to kind of make that easier? We also noticed that there was a lot in terms of setting up the chairs and the hardware that was kind of making them run that we wanted to make a little bit more robust and easier to do. So we started building all of those things out in V3. And then in terms of moving from V3 to V4, we ended up doing, again, another work in progress showing, seeing how people interacted with the chairs and use that to kind of inform the next set of requirements that we then built into the version that is live at the Beal Center. A couple of things to kind of note, I think, in terms of when I started this project. When I started, I had never built a robot before. James had been part of a robotics team in high school, so he had some more experience, but my general background in CS was more just in kind of standard software engineering. One of the things that it helped with, though, was just helping give me the tools to figure things out along the way. So even though I'd never coded a robot before, I knew how to search Stack Overflow. I knew how to find good online tutorials. And I knew how to go back to the different, departments and disciplines that I was, embedded in and part of the community of, to ask questions and find the people who knew more about robotics or knew more about hardware than I did, and be able to bring their knowledge into the team and make things work. So each of these, we kind of had a lot changing in between. And for each of them, it was really important that we ended up getting feedback from real people to kind of inform that next set of requirements. But all of this really started with Catherine's original ask, which was, I want to automate office chairs. So what did we end up building? We're going to go through the chair-specific tech stack and a kind of technical overview of each individual chair and how that chair ends up making decisions of where to go and how to move through the space. So each chair has a couple of different hardware parts on it. Over here on the right-hand side, you'll see the camera on the top right. So that's just a very standard webcam, the C270. Logitech. And then right below it, we've got a LiDAR. A LiDAR is used to kind of measure how close things are in different directions. So we'll talk a little bit more about the specifics in a minute here. But those are the two main sensors that the chair is using to make decisions. Those are kind of telling it about its environment. Then we have the Raspberry Pi, which is a small computer. And that's kind of where the chair is doing all of its decision making. That's running an operating system built for robotics called ROS, Robotic Operating System. It's kind of the brains of the entire chair. And then that is connected to an Arduino, which is another kind of microcontroller, so another small computer. And this one is kind of delegated with a lower level task of making sure that the two wheels get to and stay at the speed that we want them at. So the Arduino does a little bit more to kind of manage that. The Pi will just kind of tell it what speeds we want to get the two motors to. And then we have the Arduino connected to a motor controller and then connected to two motors with encoders, which is how the chair actually runs. And to give you a sense of the scale of these things, this is a Raspberry Pi, so it just kind of fits in your hand. And you'll also notice that even though it's a computer, there's no screen, but in order to work with it, you have to attach it to a screen. So you can imagine we had this setup with an HDMI cable, a display, a keyboard, a mouse, and then all of this kind of camera and LiDAR attached over here to the USB ports. In terms of what changed across the different versions, most of the hardware actually stayed the same, at least the kind of technical hardware of this stayed the same between the first version where we had the chairs running and the kind of upgraded version after that. We had a couple of changes that we made. Primarily, we ended up switching out to a larger Arduino. So we found as we were testing that the amount of space on the original Arduino that we had wasn't enough, and it was causing some interfacing issues between the Raspberry Pi and the Arduino. So we swapped that out. And then we also got a different motor controller. And then we got different types of motors. So motors can come with either encoders or without encoders. And encoders are another piece of hardware attached to the motor that makes it so that you can actually tell how fast the motor is spinning in that moment. And so originally we had motors without the encoders, so they would just spin and you would see, okay, I'm hoping that the chair is going to go at roughly this speed. We ended up needing those encoders in order to be able to get over the bumps in the floor and the kind of stacks of paper. So that new requirement informed upgrading that specific piece of hardware. But other than that, most of our additional work for getting each chair individually to move was mostly just on the software side of things, which we did then on the Raspberry Pi and on the Arduino. The way that each chair moves is we basically gave it a little bit of like a priority run book or a way to make decisions. So each chair individually will try to move autonomously and just avoid white paper on the ground. So kind of moving away from it if it's on its right-hand side or in front of it, kind of backing up and reversing. Unless a person is in front of it, then we want it to safety stop because we would prefer that the chairs didn't run over people. Or if a person or a chair is kind of to the side of the chair, we want the chair to speed up and kind of get out of its way. You can think of it like in an intersection. If you're in the way and there's another car coming, you kind of want to get out of the way. Unless the chair has been stopped for too long, then we want it to do more of a choreo to get out. And this was informed because as we saw during some of the work in progress showings, we'd have this great, awesome gallery opening. People would all be having a great time. They'd be chit-chatting and just kind of talking in small groups around the space. And sometimes the first time around, a chair would kind of come up to them and then would stop because it was doing the safety stop. But the people wouldn't move because they were engrossed in their conversation. And so the first time around, the team and I, we had to like go in and actually physically move the chairs back to get them unstuck. And we were like, what if we gave the chair the ability to kind of get out of that situation on its own? So if it's been stuck for a while, it can try to pivot away and try again. So that's kind of where the choreos came in. And the choreos make the data problem interesting because you end up needing to turn off some of the LiDAR functionality temporarily because you don't want it to continue to safety stop because you're trying to get it out of that scenario. So that's kind of the thinking behind a choreo. And then the last kind of mode that a chair can be in is in handwritten mode. So if an actual human is in control, either I'm testing it or there's a safety reason for a human to be sending commands to the chairs, then we want it to follow those commands. And the way that these different priorities are displayed and represented in the data that's passing through the chair is via this idea of a command. So a command is basically a way that we develop to encapsulate some of the information about, one, the priority of a specific type of movement, and then two, some information about that specific movement in terms of the left and the right motors and the speeds and things like that. So if we look at these kind of autonomous commands, this first row here, you can see that an example might be DA F3.0, F3.0. And what that breaks down to is you've got a kind of priority in your first character. So D means it's pretty low priority. This is just like a standard forward motion. We want it to be lower priority so that something like a safety stop can overwrite it. And then we have the type, so A for autonomous. And then F means the left wheel should go forward at a speed of 3.0, I believe, inches per second. I'd have to look in the code for the exact units. And then we've got the right wheel also at forward 3.0. And that's one where the autonomous command kind of goes directly translated forward and sent along. And that type of a command can come from either the LiDAR or the camera. And then we have kind of the handwritten commands, which are formatted to look a little bit more like something that a human would type. So forward, FWD, for example, backward, BWD. And that then inside of the system will get translated into a different encapsulation, again, where we're encompassing that it has like a pretty high priority because it's a handwritten command. It's coming in as a handwritten command. And again, it has the left and the right direction and speed. And then a choreography, which is represented in a bit more of a shorthand and will end up corresponding to a set of autonomous commands. So in this case, we have ACF, which might mean reverse for 2 seconds, then turn clockwise for 3 seconds, and then resume kind of normal operation. And those can also come along from the LiDAR or the camera. And this is all kind of on a single chair. This is how it's making its decisions. And you can see some examples here of some of the autonomous commands that we have loaded into the chair. And all of these we also made configurable. So what we noticed as we would kind of have the chairs running and be testing them or getting feedback on them, we noticed that oftentimes we'd want to tweak the speeds just a little bit because it would give the chair a different feeling and a different personality almost. And so we pulled these out of kind of where we had them embedded in the code in order to make it easier to adjust and nudge those types of behaviors. The entire way that the data is kind of traveling through the entire system is with a series of publishers and subscribers. So ROS is built on top of this idea of publishers and subscribers. You set up particular topics that have an expected data type, and then different nodes can either have publishers or subscribers to that topic. So they can either push messages to that topic and then other nodes can pick them up, or they're one of the nodes that's picking it up. And mostly what's important here is that it's kind of a language that is short memory, asynchronous, and each node kind of keeps track of its own state and then will pass along things that are important. But all of it is really kind of moving as one continuous pipeline all the way from an initial piece of data all the way out to, in our case, like a specific signal that's sent over to the motors to get them to move a particular way. And the full thing actually looks a little bit like this, which is kind of convoluted, a little crazy, but it ends up breaking down to something more akin to this. So we have a set of nodes that go through and process the camera input, and then those will, at the end of that set of nodes, actually go ahead and recommend a way of moving to the chair. So either an autonomous command or a choreography command. Same thing for the LiDAR. We do some processing on the raw input there, and then that eventually manifests as a suggestion for how to move. And then all of that will kind of be adjudicated by the driver. So the driver will figure out which one has a higher priority, send that along to another node, and then handwritten commands will actually kind of overwrite at that stage. And then the output of that node will go out to the Arduino. One of the things that I think is interesting and important to kind of call out here is that the end output of the camera nodes or the camera processing nodes is actually a recommendation for how to move. And I think that this is something that really showcases how the design of the software inside of the chair actually helps make the aesthetic reality of the chairs. So because we have the camera input specifically suggesting to either, move left or move right or move forward, and the LiDAR specifically suggesting to stop or to speed up a little bit or to pivot, as you watch the chairs, you can more easily see how a particular type of input or a particular piece of the environment that the chair is encountering is translating into the decision of the chair to move in a certain way. So I think because we kind of have pieces in the software that highlight or that translate into something that, you or I might be more able to explain or reason about or so. And then we have two of those possibilities being compared to one another and then one of them winning out. It's just a way that I think the data pipelines themselves end up making the aesthetics of the piece feel visible. And you can imagine, a different pipeline here where the camera input stays in a more raw format or doesn't get processed as much, or there's some sort of machine learning that runs on top of it and has a probabilistic outcome or so. All of that would change the way that the chair behaves. And I think that's just like a kind of cool thing to see embedded into the data pipeline itself. In terms of the actual data processing that we're doing with our two inputs, for the camera, the way that we process that information is we start out with an image, we then turn it black and white to make it a little bit faster to process. And also because we really mostly just care about counting white pixels for that paper. And so we don't really need kind of the other color information. We then go ahead and set kind of like bands on the sides and the top of the image. And then we'll count the number of pixels in each band that count as white. So we do that by setting a particular brightness threshold. And then if the pixel is brighter than that, we count it as white. And then we'll go ahead and count the number of pixels. And if a certain percentage of the top band is occupied with white pixels, then we consider the chair to be blocked in front of it, and then same on the left and the right. And then at the end of that, again, we have that kind of movement recommendation. So in this case, because we have paper in the top and to the right of the chair would say, let's do a choreo to get out of this. We're going to do a left reverse. The LiDAR is a little bit different. So the LiDAR basically acts as, it's like one disc and it kind of spins. And as it's spinning, it actually beams out a laser in each degree for 360 degrees. And when it sends out the laser, it then waits and counts basically until it gets the light back, reflected back. And based on how long that took, then the LiDAR knows how far away the nearest object is in that direction. So this is used on actual autonomous vehicles to kind of give you three-dimensional depth information of the environment around you. We're using it just at one cross section, and it's like roughly kind of thigh height or knee height. And the things that we really care about there are kind of this pie slice in front of the chair. So what is in front of me? Is there a person or a wall or another chair? Then I should stop. And then on the two sides, if there's a person or a chair, I want to kind of get out of the way. And the actual data itself looks a little bit like this. So if you imagine that the chair is facing towards the left, all of these little yellow dots are the actual LiDAR measurements that are coming back in. And then we push them through some open source libraries that we use to do obstacle detection and extraction. So you can see that a lot of dots kind of in a line are going to show up as a line that's probably a wall. And then dots that are kind of forming these curves are going to end up showing up as like obstacles, more in the form of people or chairs. And one of the things that we ended up having to like actually figure out how to do was making sure that the chair poles would actually show up on the other chair's LiDARs. So we had a whole bout of engineering around how do we make them like wide enough to appear on the LiDAR of the other chair, but also aesthetically fit the rest of the chair. So it was like quite a fun, small problem set of making sure that the chairs didn't run into each other. And then again, at the end of this, our output would be a movement recommendation. So in this case, we've got that safety stop. So higher priority autonomous command saying to set the two wheels to a speed of 0 and essentially stop the chair. Cool. So at this point, we've actually done everything that we need to do to get the chairs to move independently. They're taking in the camera, they're taking in the LiDAR, they're making decisions based off of it, they're roaming around the space, we can even adjust their speeds, all is well and dandy, everything is awesome, except that in order to actually set this up, we had to either me or James or Ian or other folks who were kind of deep in the like technical weeds here and had written the code had to open up. So we had to, first of all, we wheeled a chair over, we connected the HDMI cord, we plugged it in, we plugged everything in, we plugged the mouse in, we plugged the keyboard in, we started up the Pi, we then went through and, you know, we were like, this is great, we've got our little aliases. Instead of typing out a really long command into terminal, I just have to type out this short command like camera, except I have to open up 10 different windows and type in very specific commands that I have memorized and that I know what order they have to be launched in. I do this, I make sure that everything is running. At this point, right now, you can see like 3 windows open, but imagine 8 more of these. At this point, I then unplug the HDMI cord, I wheel the chair out to the middle of the space, I drop it down, and I do the same thing for 2 or 3 other chairs. This entire process takes like 40 minutes or so, and is very possible, very doable when you're doing a work in progress showing one time. A little bit harder to convince a gallery to go through that entire process. And the Beal Center is great. The Beal Center is like built to do art and technology, but this would be not a nice thing to hand over to them. So what we realized is once the chairs were running, we had a whole set of other real requirements that we needed to address, and that would take years of engineering effort to get over the line. So everything on an individual chair was running at the end of that first iteration, or that first version that I was involved with. Everything beyond that, of getting them ready to actually pass off to professional artists, came afterwards. So rather than the requirements just being, I want to automate office chairs, what we found is that the requirements were, I want artists to operate and fix automated office chairs when I'm not around. And essentially, right, we had met our intended goal, and we wouldn't have been able to figure this part out if we didn't meet that first. But it was really, really important for us to acknowledge that we'd gotten to this point and we had additional requirements, and be able to meet those requirements to be able to make the entire piece a reality. So if we look back at those versions, most of the work that we did as part of V3, and also really, really kind of digging in and building out in V4, was building out all of the things that a gallery attendant or Catherine herself would need in order to set up the chairs, tune them to a space, and then, you know, operate them on a day-to-day basis. So we thus come to the question, what did we build to address those requirements? And if we go back to our hardware diagram, one of the things that we added here, one of the most critical pieces of hardware on the chair now, is a set of antennas. So the reason that we had to use antennas was, and this is where it was awesome that Catherine is like a practicing artist who has done multimedia interactive installations across a variety of gallery spaces, because she came to us and she was like, friends, Wi-Fi, gallery Wi-Fi is so unreliable. It really depends on what gallery you're in. Some of them have really awesome Wi-Fi networks, some of them don't, some of them have like public restrictions, all that type of stuff. So Wi-Fi is going to be really, really difficult if we do things via Wi-Fi. And gallery openings, when you have 40 people in a room, all of them with phones, will really cut out Bluetooth. So we can't do Wi-Fi, we can't do Bluetooth. And we said, okay, awesome. What if we did antennas? So we ended up adding antennas to both the chair and to a small Raspberry Pi that was connected to a screen and would kind of remain on a gallery attendant's desk. So we ended up using a kind of hub and spoke model where each chair had an antenna and was a spoke, and then the hub had the hub antenna, and also, you know, had a graphical user interface, and a gallery attendant could actually like click on it and type things in and be able to operate it the way that they were more used to operating an actual computer. So even though this might seem like overkill, of like doing this kind of involved networking, and it required a lot of engineering, we had to really hack those antennas to get them to work. It's been one of the most important pieces or parts of the solution that we built out to actually have these chairs be robust. And so if we think about the parts that a gallery attendant or an artist can see and have access to, in this new scenario, they can kind of look at the light on the camera, they can look at the light on the Raspberry Pi, they can look at the light on the LiDAR, they can look at the light on the antenna, and then mostly they have this hub to work with. And they're going to want to be able to answer things like, what state is the chair in? Is the camera online? Is the LiDAR online? Is something broken on the chair that I need to fix? Or have I forgotten to turn something on, or do I need to restart it? But also, they need to be able to send specific commands over to the chair. They need to restart it in the case of kind of something going wrong, them swapping a part. They need to be able to shut down the chair at the end of the day. And most importantly, throughout the course of the day, they need to end up swapping batteries. So we have a kind of hot swap mechanism so that the chairs will stay continuously powered on while the show is up. But they need to actually swap those batteries, because otherwise the battery will just die, and pulling the power on the computers is never really ideal. So we want to avoid that as much as possible. So those are kind of like the daily operations. And then in terms of if things go wrong or if we're setting up for a new space, we also needed them to be able to know when to hot swap different parts, how to hot swap them, some basic debugging if we needed to, and also being able to tune to the space. So if there were specifics of maybe the floor being shinier in one gallery than another, so we need to adjust the brightness level for the camera, or maybe there's a reason that the speeds need to be adjusted in another environment because it feels too fast, or things like that. All of those were parts that we wanted to also be able to do from outside of the chairs. So a couple of the things that we did at a very high level, variables that we knew that we would need to adjust over the course of the lifetime or as part of the tuning process, we pulled those out into kind of like configs that we could load up at runtime so that we didn't need to change values in code and have the code recompile and things like that. And then we also built a lot of our own tools around like helper scripts and tools to make it easier to tune to the space or to kind of test different configurations. And then we also built out a whole graphical user interface for folks to use. And then Catherine built out a really, really awesome operating manual to send along with not just the chairs, but the other art pieces so that people could kind of get some frequently asked questions answered and also learn a little bit more about the technicalities of how the chair was operating, enough to be able to work with them. And then lastly was kind of making sure that as we were designing things, designing with swappability in mind. So figuring out how to, for example, copy all of the code off of one version of the Raspberry Pi so that if something happened to that Raspberry Pi, we could swap it out with another Raspberry Pi and the chair could just be back up and running. In terms of what that meant for our data pipeline, we realized that there were two really important messages that would tell us whether the camera was online and whether the LiDAR was online. So Ross has this really cool like extra default node called stats that will tell you some statistics about the rate at which certain topics are being published. And so we ended up kind of looking at that stats information for one of the kind of end outputs of the camera nodes and one of the end outputs of the LiDAR nodes. And we said, okay, if that, message isn't being published, then we know that the camera's offline or the LiDAR is offline. So we kind of built some monitoring into our pipeline in order to know which parts of it were running or not. And then we sent that information along with some of the other state that's kind of distributed across the pipeline from each individual chair back to the hub via like a heartbeat signal going through the antenna. And then we also did a little bit around designing those messages so that each chair had an identifier number. And the hub could then also send messages to individual chairs, and chairs would filter out messages that weren't meant for them. So we did a lot in terms of kind of setting up that connection to make it more robust. In terms of the user interface, this was my first draft that I built out, which I was also in part building out for myself. So as I was going through and started to have to test more complex behaviors across all of the chairs, it became harder and harder to keep them all like hooked up to different screens or to swap between them quick enough to see what was happening or how one command that I was sending over to them would affect other chairs. And so I ended up kind of having each chair send me more information about its state. And then I used that to kind of help as I was doing some of the tuning and debugging during the actual software development. So that's why you can see things like T, D, EOC, those are specific flags that have been set in the chair. And then I made myself little shortcuts to test different functionality on the chairs. So you can see that I have ways to kind of test a broadcast or ways to stop each individual chair or so. And then I'm also keeping track of the most recent message. This was all very good and useful for me as someone who knew the depths of the software, was trying to, understand the software, but it was also really, really specific to me. I remember Catherine coming up to me and asking, like, what is EOC? And I was like, that's a great point. It does not make sense if you don't know what that flag means. So before we handed this off to the gallery attendants, the docents, and the Beal Center, we slimmed it down a lot and made the critical information stand out more. So now we have kind of the individual chairs, and we realized that unless someone is in debugging mode, they don't really need to tell the chairs to go forward or backward, because oftentimes the only handwritten command that they want to send in an emergency is the stop command, and then tell the chair to kind of go back to its autonomous mode afterwards. So we pared those down. We also made it a little easier to kind of send things to all the chairs, and to also see when the camera's online or the LiDAR. And then in the top right, I'm especially proud of this, we added a countdown for when the battery needed to be changed. And when it got all the way to 0, it played a sound to get a gallery attendant's attention, which I'm particularly proud of, because even I, when I was spending hours kind of working on the chairs, would forget to swap the batteries, and having this little reminder was just so, so useful. So those are kind of the main components that are at work here. And all of this now starts up by just double clicking on an icon on the desktop. So a much, much easier kind of way of starting. But in the background, all of those scripts that I had written for myself to make it easier to continuously restart these nodes and kind of get everything running, and some of the automation that I had built in for detecting the right port, like the right USB port and things like that. All of it was still there in the background, but we put a better kind of like first layer on top of it that someone could interact with who didn't have all of the background about the kind of specific things happening under the hood. And then we also added a way to select which chairs were online. And this was because a lot of our logic was kind of dependent on making sure that all chairs sent some information back. And in order to swap out chairs, if we needed to, we needed to be able to quickly update the active chairs. So that was kind of another part that we built in. And then I think another thing that's important to call out here is that all of this was on the software side of things, but there's actually like a really, really key part of making people comfortable interacting with the chairs, which is that, and we'll get to a picture of this in a little bit, but each of the chairs had a kill switch on the back. So kind of like a red switch that someone could, if things were really going wrong, just go and hit, and it would just cut power to the motors, but not to the computers. And it was a really easy way to give someone in the moment, if something's going wrong, you can just hit this, everything will pause, and then we can get things figured out. You can just move the chairs and then hit go again. And I think that just does a lot to be able to give someone a sense of like being able to handle something if something starts to go wrong. And then in terms of some of the tooling that we built for ourselves, here's another example of one of the interfaces that we built. So this is one of the ways to test different brightness values and different bandwidths for that camera configuration that I was talking about earlier. So you can see here that as you move those around, you can see what this particular image input would actually be processed as inside of the chair. Sweet. So those are kind of all of the technical components that we were working with. And a lot went into how we got to each of those decisions, both as like what we wanted to build, but also why we needed to build it and how we wanted to build it. And I think a lot of those emerged out of how engineering for artists is unique. So one of the things that I think is a really, really interesting outcome of this project is that the most technically robust solution isn't always necessary, and aesthetically might not even fit with the project. So going all the way back to some of those initial thoughts about seeing the chairs making actual decisions, seeing the decisions pass through the data pipeline and see different decisions kind of be held up against one another and reprioritized and things like that. All of that ended up giving the chair a different sensibility than if we had gone with one of the more engineered solutions. So another way that we could have built out this whole project is by leaning on some more, honestly, like standard, but also advanced robotics algorithms. So one of those is called SLAM, simultaneous localization and mapping. And for that algorithm, a robot will basically move around a space and collect a bunch of data about how close different things are and kind of like what obstacles it runs into. And from that, it'll build a really detailed map of its environment. And once it has that detailed map, it can then set very specific waypoints throughout it and very quickly and smoothly move between them. And there were a couple of things about the actual setup that made this a little difficult. One was that there would be people moving in and out of the space, so some of those obstacles wouldn't remain and the map would get a little fuzzy sometimes. Also with the white paper on the ground, that also complicated things. But there were all of these like even more advanced SLAM algorithms that we could have reached for instead that did more about like computer vision or machine learning or, excuse me, things like that. But it would have resulted in a very, very different type of chair. And so I think one of the things that is cool about doing this kind of thing for art, where the aesthetic sensibility also matters, is that you can start with a kind of easier solution and actually get a reaction to it and see whether it meets what you want it to do, or even maybe see how it informs the next step that you decide to take. And it doesn't always have to be the most technically robust one to be the right one. Very relatedly, seeing how people interact with a piece will inform the engineering requirements. The first time that we kind of showed the chairs to people and saw how people interacted with them, so many of the key parts of our next set of engineering became really apparent. So we realized that of course people would try to trap the chairs. Okay, how do we give them some way to rebel or some, way to even detect that they're trapped? We realized that the thing that I said about the kind of gallery opening with people standing around and chit-chatting, right? Sometimes people will be near the chairs but not interacting with the chairs. How do we help the chairs kind of get unstuck in those scenarios? Even just getting into a space. When we were originally testing these chairs, we were on like a very hard carpet and the chairs were moving around totally great. And then we got into the space and it was this really hard floor, and all of a sudden the chairs got a little bit stuck and we realized, oh, we need to like add a little bit more padding to the motorized wheels so that they're always touching the ground and there's just like more drive to them. All of these types of things are only going to become apparent when you put the thing in front of people. And I think that's just like a really cool thing to lean on. And it's no surprise that each of our major versions ended with and then was informed by a showcase or a work in progress showing or an opening, like giving it to people and seeing how they react to it. And the other thing that I'll say here is that seeing people interact with the piece also isn't even just necessary for the engineering part of it, but I think it's a huge, huge important factor in terms of keeping the motivation going for a piece like this. When you are deep in like the bug and it's taking you 4 days to figure out why the antenna isn't working all of a sudden, it can be incredibly demotivating, or you can think that like the whole piece isn't a success if we don't have this part working. And seeing people interact with the chairs or just seeing them roll around always gives me so much new enthusiasm and motivation and just excitement and like a real feeling of tenderness towards the chairs. And I think that that's also something to keep in mind, right? Like, how do you get people to react to the thing you're building so that you remember why it's cool that you're building it? Another thing is that, and I think this, again, it kind of comes out of a lot of the learnings that we had around what we had to build to even be able to pass this off, is that you have to engineer not just for a piece's behavior, but for the piece's maintenance. And a huge part of that will also involve putting things in front of people, seeing how they react to it, right? Seeing that EOC doesn't make any sense to someone who doesn't need to know that information, and you can actually just hide it and it'll make the entire thing easier to work with. Thinking about how to hand off the tools to someone so that they can operate the chairs on their own is going to also involve a whole lot more engineering work. And in some ways, the piece without it continues to need to be maintained by the people who originally built it. And I think one of the really cool things about art is that it often moves from gallery to gallery. And so an art piece, as it stands, will typically have multiple people taking care of it at different points in time. And you get to provide the tools for them to make that like a really good experience, which is awesome. And then kind of related, you want to build or use tools to make it easier to test and run the piece, both for yourself and others. So this is a photo of one of the kind of like slimmed down versions of the chairs that we were working with at one point, where we really needed to just test the wheels and the motion, but we didn't need the entire chair to be set up. Figuring out how to build those kinds of test scaffolds, harnesses, shortcuts, scripts that you run, all of that to make it easier to kind of do iterations on hardware and on software is always just really, really critical. And also just a critical part of like making the experience a fun one for yourself. Cool. Stepping back a little bit from the art specifics and thinking a little bit about what it means to be involved in an interdisciplinary project in general. Thinking about what advice I would give to others who want to get involved in interdisciplinary projects. The first thing that I would say is that you want to find your connectors. So on this photo in the back in a white lab coat is Tom Bray. Tom Bray is, I think he's technically the technology consultant at one of the libraries on campus at UMich. But really he's like mostly just a wizard and someone who will help get things done that you need to get done. Tom is like the person that you go to when you need to find a particular part or get access to some sort of tool or just need help getting the final mile. And these types of people are not just at UMich, they're also at UC Irvine. They're also at most institutions or in most communities. You just kind of have to find them. And the cool thing about connectors, and oftentimes interdisciplinary projects are just like rife with them, is that each of the people who are kind of helping to bring an interdisciplinary project to life often are part of their own institutions or disciplines or specialties and can bring the resources that are kind of encompassed in that to the project. So I was able to, you know, as a student in the art school and also a student in the engineering school, I had access not just to like resources, shop materials, like hardware in those spaces, but also the people. So I could go to my professors with questions. I could go to my friends with questions. I could ask them if they knew someone else. And I think figuring out how to get a person on the other side who can kind of be your welcome into another institution or so is just really, really huge. And is also just, I think, a way that you can build out things that are bigger than your own knowledge base. So going to the kind of second thing that I would tell people is you don't need to know how to do the full thing. No one on an interdisciplinary team is going to know how to do the whole thing, typically. And I think that's one of the coolest parts of it, is that by bringing the team together, you get to build something that is larger than the sum of your individual skill sets. And again, right, I had never coded a robot before this. I also didn't know what ROS was. Catherine came and was like, I heard about ROS. Let's try to use ROS. And I said, great, let's go figure out what ROS is. And I think there are so many ways in which you can lean on other people. You can also lean on the existing skill sets that you have, especially as data scientists. There are so many ways that you already know how to think about data, how to Google like error messages, how to find good resources, how to validate hypotheses that can really easily be applied to things that are pretty adjacent, even if you don't yet know how to do it. And I think in a similar vein, oftentimes an interdisciplinary project or a personal project in general can be a really great way to learn a new skill and kind of grow in those ways, because there's less pressure to be 100% correct about it, and you get to have fun with it along the way. Another important learning, I think, and this kind of goes to the fact that you're bringing so many disciplines together, and you're all kind of bringing different perspectives to the project, is that you want to build in time for iteration and you want to get feedback early and often. The number of times where we'd be building something and then seeing it actually in the space, or seeing Catherine react to it, or seeing someone else react to it, it would just often really recrystallize the thing that we were building and either pull out the important part about it that we needed to focus on and really figure out, or the part about it that we could drop and we realized wasn't actually that important, or some way that it was opening up new ways of thinking about the project or new things that we might want to build out. Just really no way to state it differently. I think the more you can kind of get those cycles in, the better the piece will be. And you just want to make sure that you have enough time for that, and that especially if you're going, again, between disciplines, you want to make sure that you get feedback across those discipline boundaries. So even though, you know, we had the software crew kind of crunching away and building out some of the software, it was important for us to get feedback from everyone else on the team so that we didn't get too deep into our own, you know, way of seeing the world or way of doing things. And in a really related way, you want to make sure that you plan for different perspectives. So this is in our original workspace. It was an old, like, dance studio psychology space. We had like a mirror on the wall. Catherine is on a Zoom call with us, and we're showing her some of our engineering plans that we've written on here. And I think it's just a really great way of encapsulating that when you're, you know, working on a project like this, everyone's going to be bringing different perspectives to the project, and everyone's going to, even though they're looking at the same data, they might see totally different ways of processing that data, or things that are exciting about that data, or things that that data kind of highlights as important things to think about. And you want to make sure that you have enough time to really give people time to share those different perspectives, and then to figure out how you're gonna work with all of them. And so I think just making sure that you know that that will be a part of the process, and that you give yourself the space and time to really dig into it is important, especially because that's where all of the exciting stuff is. So you don't want to miss out on that magic. And with all of that said, I hope that you all, in your own interdisciplinary projects, or maybe in new interdisciplinary projects, have the chance to also get to work on some really cool things. And maybe you also have a chance to go out and see the chairs in person. As I said before, they'll be up until April 20th. There are also some really, really awesome other art pieces on display there. Catherine has a really, really fantastic set of works on display. I also helped with another one of the pieces, the hand sanitizer dispenser. So if you get out there and you interact with it, you'll have a whole second art piece to think about that I got to help build. And with all of that, I just want to say a huge thank you to all of you for your active engagement and listening, and also just again to Brian for hosting me here with the Masters of Data Science program, and also to Chris Pounds for kind of making that initial introduction, and the Beal Center obviously for hosting the artworks, Catherine for bringing me into this entire project, and every other person that we've kind of leaned on like along the way. Even all of the names that I mentioned was just a small fraction of all the folks in the background who made this possible. So as we had in like hung up in our original workspace, thank you. You folks are amazing. And with that, I'll open the floor to questions.
Thank you, Faye, sorry. That was an amazing talk. Thank you so much. I really enjoyed it. I learned a lot about the thought process of bringing interdisciplinary areas together. It's really amazing work. I'm excited to see it here on campus. But we'll open up to questions, utilize the Q&A or come off the mic. Thank you again. Wonderful talk.
Thank you. I don't bite, I swear. Yeah, Athena. Oh, I think you're muted.
Great talk, thanks so much. So I have seen the show, so I have that advantage. So, and your perspective of describing this was from the perspective of an engineer supporting an artist. But in your day job, you're also an engineer or a data scientist. So do you ever think of the opposite direction? So we have all these ideas we're trying to convey from the technical world. What is the right way to engage an artist to demonstrate these ideas?
Yeah, I think it's a really, really great question. And it's one that, so while I was at UMich, I was a student representative on this like small grant committee where we would give grants out to interdisciplinary teams. And one of the things that we talked about a lot on that committee was how to make sure that a project, when it was bringing together different disciplines, was actually kind of creating space for each of those disciplines to bring their own expertise into the room. So one of the things that we would talk about a lot was if there's a combination between an engineer and an artist, for example, is the artist just being brought in to like make a pretty poster? Or are they really being brought in as a collaborator, as someone who is going to bring expertise or a new way of even interacting with the data, who will see different things in the data because they're used to thinking creatively, who is also maybe going to be trained in like asking questions that will highlight some of the underlying assumptions of the data in a way that will bring something new to the project. And so I think in terms of like thinking about what artists can bring to a project that is kind of starting out in the engineering space, I would say making sure that an artist has the space to ask questions and to also use that question asking as a way to dig into how the engineering is affecting other things. Almost like thinking of the engineering as the basis of an artwork and the artist is helping you like critique it and then pull out parts to really develop on the next round around. I think that's really critical. And then I think part of that also just comes from making space for, I think in those types of combinations, there's like a whole historical way that engineering has engaged with the arts that can sometimes make it hard for artists to like really take up the space and be taken seriously, even when they're pushing against some of the standard ways of doing things in engineering. And trying to just open up that space across the entire team can do a lot in just making it easier for them to bring their perspectives to it.
Thank you.
Yeah, Jesse.
Hi. I'm
Jesse
sorry, I
is
missed your
also
screen.
the curator of the show. So huge thank you to Jesse for putting the entire show together.
No, and Faye, thank you everybody for being here, and Faye for this wonderful talk. Can we hire you to give that speech to like every engineer? Because that's the speech,
would
right?
love to.
That's it in a nutshell. Is that and look, all the engineers here, all you need to hear is just have the artists get involved early, and vice versa. If you're going to do a collaboration, the key is to have all the people in the collaboration involved as much as possible from the beginning, and that's not always possible. This is just me editorializing for a minute, but if it is, if you conceive of something from scratch and you want to involve both groups, just because otherwise you don't give them the space to have a conversation. Faye, my question was, what, if anything, do what's the kind of, there's always the secret things that are left off the table or on the table. What do you wish they could do, in version 3 or 4? Like, is there yeah, what, and by the way, everyone should come see them. I mean, please come to the Beal Center and check them out.
Yes. I think it's such a great question. I think it's so funny because there are like all of these little things along the way that we've talked about of like, oh, imagine if the chairs could do this. And one of those things was right now, all of the chairs are kind of tuned the same. So all of them have the same settings for moving forward, the same speeds for turning left or so. At one point, we were like, how cool would it be if they could each have slightly different personalities? And you could have one chair who's, you know, a little bit more like fast and loose and just zooming around a little bit more. Another one who's maybe more hesitant or so. So that's one of the things. The other one is a whole way of having the chairs move that James built out, which we haven't, you know, been able to run or test yet, which is actually and this was built out with the idea of what if we ever end up in a gallery where we can't set down enough of that kind of black marley flooring to give the chairs a space to move? What if it's a smaller gallery or so? And James built out this way of having the chairs be social or antisocial, where they would actually start leaning more on the LiDAR and would move closer to the walls and kind of be a wallflower and really kind of hover near the wall and move around in that way, or would try to stay as far away as possible from the walls and would move around in that way. So I think that's another one. And then the last one is you know, having the chairs be able to rebel. This is something that's built into the chairs, but it's one of those things where if it happens too often, it takes away from the agency of the chairs. And so figuring out how to really tune it just right, that when one of the chairs gets trapped, all of the chairs are able to like rebel in unison with that trapped chair. But having it happen at, you know, like the right point in time, you've waited enough, it's the right type of trapping. That type of thing is something that like is there in the piece and is possible. It also needs to be held with like a real lightness in order for it to land right.
Yeah, I mean, the lived experience of them is that we anthropomorphize them very quickly. So they do have personality to us at the Beal Center, even though they don't, and they get their parts swapped out, and we don't know which brain controls which one at any given time. But I mean, any little behavioral shift and when they do so it's interesting how a little tweak, like a little bit more of that, or if you could like parametrize these different qualities and even just slight shifts in speed on a little like slider thing just to mess with people. It's like, what are they going to do? So that'd be really, it'd be hard to calibrate. You'd have to test. You'd want to like see so many different permutations of those variations, but it would be really cool.
Yeah.
But they already have personality. They're not just 1, 2, and 3 to us.
I know. And even some of the hardware will just have a certain personality. Like some hardware will just love to give you a hard time. And you're like, oh, it's, you know, number 4. Like harness number 4 is having its day today again. And we're going to figure out how to get it to play nice. But it's
and every
really
once in a while, one of them tries to escape. So that's the best,
exactly.
That's the most exciting thing that happens. But it's very rare. It's already a very rare occurrence.
Exactly.
I'll leave. Thanks again, Faye.
Yeah, thanks, Jesse.
Any other questions?
And we also have, you know, I don't want to put Catherine on the spot, but if Catherine wants to either on chat or also via audio or video, you know, give her perspective on any of this, more than happy to open the floor.
Henning, please come on now.
Audio issues. 1 second. Okay, we've got a bit of troubleshooting happening. Hello, Catherine.
I just wanted to say thank you so much for an incredible talk. This was really, I always learn from Faye whenever she is trying to explicate the work to me. I really learn something new every time. So thank you so much for a beautiful talk. And I'm really happy to hear that the recording might be available. I think that there are so many folks who would love to hear this. So thank you.
Thank you.
Yes, we will make the recording available to all of you. We'll upload it on our YouTube channel through our UCI media, and we'll also have an article paired with it as well, so you can revisit the recap. Zach, please.
Hi, thank you so much for the really fantastic talk. One thing I'm wondering is, how do you wish like your day job or more traditional engineering was more like working with an artist?
Oh, it's such a good question. I think one of the things that I really, really love about working with an artist is that aesthetics and affect and like how a thing affects people, like just in a moment, matters as like a real consideration of the work. And I think that there are so many ways in which like engineering decisions that we make as we're building software or so, right? Like the number of times that I have used a UI that makes my day bad, like that just really frustrates me in some way that is hard to explain. And even if I can get the, thing done that I need to get done, it still leaves this bad taste in my mouth. I think oftentimes in kind of traditional software engineering, there is this way of thinking about that as like that's a fine price to pay or to ask someone to pay so that they can still get the thing done. And I think I really just love that art takes that into consideration and just weights it a little bit more equally to the other considerations of the project. And sometimes I just wish that there was a little bit more space for us to define like key performance indicators or like things that make a project a success outside of really numeric values or things that are more traditional to like software working quote unquote correctly. And there are spaces that are doing that, but it's also harder to quantify. It's like harder to even just pull out or encapsulate. And I think that's one way that I wish kind of traditional software engineering felt a little bit more like working with an artist.
Cool, thank you.
Yeah. Yes, Henning.
Let's try if that works now.
Yes.
Can you hear me?
Yes.
Oh, nice. Okay, we plug the headset in. Full
Awesome.
disclosure, I'm Faye's dad.
Yes.
So, and we're huddled here in our living room in Michigan. Awesome talk, Faye.
Thanks.
What I see is I'm an studied engineer and work in management, and I'm sometimes forgetting that engineers have to be creative. And what I see is that that's the bond between artists and engineers. And I really enjoyed how you explain everything and it's awesome to see how you do it with your hands and you're fully engaged, and we can see how much blood, sweat, and tears you put into this. And it's when you're stuck in your day job and you're frustrated and you work with a lot of smart people, but they cannot explain what they want to explain. And then seeing a talk from you like that is really encouraging, is awesome. So very, very good job. And I hope a lot of other people will see that.
Thanks, Dad. Yeah, I think like and it's funny because when you get engineers that are like working on something creative and they get to geek out to you about it, they are over the moon. It's awesome.
Exactly.
And I think it's just like one of my favorite things is watching people geek out about something.
That
Yeah,
was
totally.
extremely wholesome and beautiful. Thank you for that. That is really unique to hear, and that was really special. Thank you.
You're welcome.
Oh, Athena had another question in the chat asking about giving the chairs personalities. Are you thinking to do it through ChatGPT? So I think in this case, actually, so it's funny because the chairs used to have, in one of the earlier iterations, they had this small speaker that would play a little bit of sound for each of the chairs. But they never really spoke or worked with words. It was always kind of based on movement. And so I think ChatGPT just being based more in kind of like language as a whole probably wouldn't be the approach that we would take. There might be an element of the kind of like non-determinism that is backing ChatGPT that we could maybe think about building in. I don't know, like kind of adding an element of randomness to decisions that the chair is making, or even like speeds or so, or seeing it, like slowly get slower over the course of the day or something like that, I think would probably be a little closer to how we would give it different personalities. But Catherine, if you have any ideas here, also all ears.
Well, I think one of the things that you already talked about is something that I also hope that we get to try to experiment with. We had talked about social butterflies and wallflowers as two possible personalities, and I would love to try to iterate that in a future installation.
Yeah. I
When
just
it,
love the idea of a chair like kind of crawling up to you and following you around for a little bit because it's like a little dog almost. So cute.
Exactly. One of the things that, so, I really want to say so much of this, of the affordances and constraints of what we can do with the chairs are the direct result of Faye and also the others on the team. And so James had talked to us. James sort of like really took charge of the LiDAR early on. And he had talked to us about the way the LiDAR sees space, it encounters obstacles as either like edges or curves. So something that's like a straight line, we would assume to be architecture, and something that's curved, we would assume to be something organic, like a person or another chair. I guess it's not really organic, but we use the distinction architecture and agents to think about how it might encounter those two things. So, I started to think about ideas about the personalities of the chairs based on that kind of distinction, based on the difference between how a chair might encounter architecture and maybe hug the edges of the walls versus how the chair might encounter what we were calling an agent, a chair or a human, and maybe gravitate toward or shy away from those. So I think that's something that we could build out in a future version, maybe.
Totally.
And
And
it
James
really
Westcoast with like great code for it too.
amazing.
Rena had a question. Rena was asking if we ever think of getting the chairs to scream help when fully trapped or move if they're trapped by people like road rage, but for the chairs. It's so funny that you asked this, Rena, because in one of the kind of earlier iterations of this, when the chairs each had their speakers, we were testing out different honk sounds exactly for this purpose. We were like, all right, so the chair is going to be stopped. Then it's going to wait for a little bit. Then it's going to honk because it'll tell people like, beep, beep, get out of my way. And then it'll wait a little bit. And if they still haven't moved, then it'll back up and do the choreography and, turn around. And so I think we did, think about giving them a voice, so to speak, and really have them move people in that way. And then the other way that we thought about it was really thinking about like if a chair can't move, if it's been trapped by paper and it's just going in circles and circles and circles, how can we use that antenna structure that we've built up to have a chair be able to signal out to the hub that it's trapped, and then ask the hub to do something, and the hub could tell all the chairs to do something at the same time. So kind of like rebellion, like standing with the other chairs type of thing. And so that's another way that we thought about giving the chairs some more agency. Oh my gosh, I love it. We can also have a sheepdog chair, Chris, absolutely.
All right, I want to be respectful of Faye's time and everyone's time. Thank you again for joining us. Any last questions before we close out the session? Again, beautiful session, Faye. It's amazing. It's great to see all your collaborators join on the talk and your dad. It's really, really nice.
Thanks, Brian. Thanks for having me.
Yeah, of course.
And thanks also to all of the, both all the friendly faces that I see in the audience and also all of the new folks that I got to meet tonight. So thank you all.
Thank you, and be on the lookout for the email from us. Our writer here, Karen, is going to be doing a piece. Thank you, Karen. Once that comes out, we'll send an email, a follow-up with the video link to it. But thank you again, Faye. It was amazing. Glad to have you. I hope to bring you back in the fall and in future events. Catherine, you're also more than welcome to come and join us. Thank you again, and everybody have a good night.
Thanks, everyone. Go see the show. Bye.